Okay, so welcome to Financial Algebra. We're in quarter 3, week 5. And this week, what we are going to be looking at is we're going to be looking at some converting stuff because in this unit, it's important to be able to convert from like miles per hour to feet per second. So we're going to focus on that one. And we're talking about cars and their stopping distance. And I like this section, but it's just because my ulterior days, I would love to look at crime scenes and car accidents, not why the people are still there and bleeding out, but kind of reverse engineer them to see how they all went. So while we're doing that, if you'll vote in the poll, that'd be great. So I'm looking for one answer. You're going to mark the true statement or statements. Ready, set, go. And you can totally guess. We're going to look at how to do them and after we talk about our discussion. Okay, so you done picking? Okay, I love that you just did that. So when we get to the PowerPoint thing, we're going to talk about which one or ones are correct. So now we're going to focus on just think of a time that you have had to use conversion of units and describe the situation and the strategy you used to convert the units. So why don't you think about that? I'm going to give you 30 seconds to just, think and pause, and then you can start writing. And I'm going to start writing an experience in one of the student pods. Okay, so Taylor, I'm going to go ahead and read yours. The time you had to convert was when you were doing an assignment using kilometers and meters. It was the most recent, but also looking, baking can be an example. Yeah, that was actually going to be my example, was a baking example. I got a, was trying to figure out the butter that I have comes in ounces, and so just making sure that I was doing ounces and cups. Yeah, or if you're doubling a recipe, I usually don't double a recipe. I usually 1.5 times a recipe. So anyway, just making sure that sometimes I've had to figure out tablespoons and cups. So yeah, yeah. So baking is definitely a conversion, and sometimes you get those ones where they're talking about milliliters. Anyway, so cool. I like your examples. Thanks, Taylor. The one that I was going to share, I typed it in Student 3. My brother, he went to Germany, and he was kind of excited. They rented a car and were excited because it looked like gas was about $2 a liter. Taylor, do you know why that's a bad sign? And if you don't, that's okay. Yeah, good question, Taylor. I don't care whether you put it in the chat box or in your pod. Either way, it's fine. Do you know about how many there are liters in a gallon? It's just an approximate, but you know. Yeah, it is about 4. Good job. I'm impressed. And so in other words, and I'm just going to type this real quick. So it costs about $8 a gallon. And my brother had gone over, yeah, it's not cheap at all. But when you see the signs for gas, $2 or whatever's equivalent to $2 because I don't really remember if France uses francs and I don't remember what Germany uses. Dinars? I don't know. Do you know, Taylor? The currency in Germany? I don't. Um, but anyway, so you see a sign for gas and it's let's just say it's like $2 and then you're like, woohoo, that's cheap. And then he goes to fill it up and then he remembers that it was per liter and it takes four of them. So then he realizes that, he's paying a lot of money for filling up this vehicle. So anyway, conversions and understanding the sense is important. So let's go ahead and we're going to find student one, sticky up there, and then the rest of this stuff in case I need it. You know what, Taylor? I want you to overtake another one. So if you want to, so Taylor, I'm going to have you take over student number 2 because I like to keep your stuff there. And if I think you could probably copy and paste your name. It'd be interesting to see if that works. Try copying and pasting your name from the other one. Anyway, so, oh, it did work. That's cool. So now you still have a really cool one. So we're going to talk about reaction distance. Now in the week, we learned that reaction distance is the moment when you see, or the moment from, so you're going to see a car accident in front of you or kids start to run across the road or something, and it's from the second that your brain sees it to the second that your foot steps on the brake. Okay, so that's reaction distance. And we're going to, well, that's reaction time. That's reaction time. But how far did the car go in the time that you were processing that? And that's your reaction distance. Does that make sense? Did I totally make that discombobulated or true? So let's go to our PowerPoint. Change colors because I like colors. Nope, we want to write. We want to write. Nope, we want to write. That's not right, is it? That is. We want to change colors. So from our previous spot, we're just going to remind ourselves that we picked true here. Oh, totally missed the circle. And true there. And then we didn't pick anything there. So I'm guessing that meant a false. So now we're going to go ahead and see where we're at and see how awesome we are. So if we want to know 2 miles per hour, I'm going to write it this way. All over hour. And the way that I work conversion might be a little bit different than what you've seen before. We want to change our miles to feet. Do you remember how many miles are in a foot? No, just kidding. The other way around. How many feet are in a mile? This is one that everybody in Denver should know. He nailed it good. So 2,000, just kidding, 5,280. And do you have a calculator handy, Tyler? Taylor? Why am I calling you Tyler? Taylor? Yeah, got it. Okay. So maybe you'll want to get it ready because, okay. So that was converting my miles. So and now we're going to convert our hours. Do you know why I did this box here? Do you know why I did this? It's not work. Oh my goodness. Oh, that was weird. I have no idea what just happened. I'm going to do Control Z though. Oh, made it go away. Nice. Let's try this again without pushing buttons. I think I was somehow pushing a button. Do you know why we multiply by that? Yeah, and the net effect is that it actually equals 1 because 5,280 feet divided by 1 mile or 1 mile divided by 2,080 feet, it's the net effect is 1. So I can multiply anything by 1, but we're just going to make it look different. So now we're going to convert our hours. we want to convert our hours to seconds. And we're going to do baby steps in that. So how many minutes, and we want our hours to be out, just like this mile is going to cancel with that mile because numerator and denominator. So that means we want 1 hour to be up. So it can cancel with the denominator down. Good. So how many minutes, we're going to do baby steps, minutes are in 1 hour? Nailed it. Good. Okay, so now that we've got that step of conversion, then we can go through and we can cancel my hours. I need to change how I'm writing that. And then let's convert our minutes. So minute. And we have 1 minute to how many seconds? 60 again. Good job. So then we're going to go and we're going to cancel everything that we can. So I'm going to cancel my minutes from the numerator and the denominator. And then we notice we still have a feet. So I know my answer is going to be something with feet. And then we've got our seconds. Okay, and then what do we do for the rest of it? Yeah, we can start that way. What I would do, this is just me though, is I'm going to take 2 times 5,280. Oh, you lost a 2. Okay. And then we're going to divide by 60 once, and we're going to divide by 60 again. So while you're figuring that one out, you get your answer and I'm going to go find my answer. So what did you get? Did you really? I don't think it's that big. Okay, so you're going to take 10,000. Good. Okay, divide by 60. Okay, now divide this one by 60 again. Nice. Because see how there's 60 in the denominator twice? Okay. Okay, so this one happened to be false. I think the other ones are true. But do you kind of get what I'm doing? Kind of get what I'm doing? Okay, so we're going to, the other 2 are true. First one was false, but that's okay. But now that we know how to do it. So now what we're going to do is we're going to look at it in terms of how our assignment will use it. Okay, so we already talked how many feet are in a mile, and you already told me that was 5,280. Kidding. And then how many seconds are in an hour? You know how to do that. Do you remember? But you know how to find it, right? Okay, so what we do is how many minutes are in an hour? Good. And then we're going to times that because each minute has how many seconds? Yeah. So there are 3,300, oh, not 3,300, Control Z. 3,000, that's what it is, 3,600. Okay, so if we want to, we can still use the parts of 60 and 60, which I will, or we can use the conversion 1 hour equals 3,600 seconds. We can use that as our conversion too. You know how we used the fraction before? We can just use one fraction if we want to. Okay, so this is what we're going to do is we're going to convert 40 miles per hour to feet per second. So all we have to do is multiply. I got to change colors. I can't use these colors. We got to convert the hour. Whoa, I keep pushing a button. Got to convert the hour. So we're going to have 1 hour in the numerator because we want them to cancel. And then what are we going to do? Do you want to do 60 minutes or the 3,600 seconds? Because we want it to go to seconds. Okay, so we're going to do 3,600 seconds. And then we're going to times it by, we want to get rid of my mile. So what do we want to put in the numerator? Good. Good, and I like that you realized you wanted your feet there too. Feet are always a good thing to have. They help you walk. So we're going to go ahead and cancel what we can. Okay, and then we're going to do 40 times 5,280. I forgot my 2. All over, and that doesn't really look like a 4. Now it does. To 3,600. And then we're going to do feet per second. So what is that? Okay, so crunch those numbers so you make sure you got the process in your calculator right. Okay, and I'm going to get super picky. What do you think I'm going to get picky on? Yeah, you nailed it. Good job. See, you nailed it. Awesome. So let's work a problem. Oh, that was what that space was for. See, I have all that extra space. Okay, anyway. And there we did it. And so now what we want to do is we want to talk about, so we have our answer. What was it? That was 58.7 feet per second. Okay, and so with this, we're going to assume that it takes 3/4 of a second to react. What do you think that has anything to do with it? What are we going to do with that information? I like that you're eager to convert some more. Okay, so I'm going to write a really small formula. So we're looking for the reaction distance. So I'm just going to abbreviate. Reaction distance equals speed times reaction time. Okay, and just as a reminder, our speed, if I were to tell you that I go 0.05 miles, you're going to go, that didn't really help me. So this one we usually want in feet per second. So we've already got that spot. Okay, so now my reaction distance Delayed reaction. Equals 58.7 times what? Nice. You're pretty awesome, Taylor, by the way. And this will give you an answer in feet. So what's our reaction distance? Okay, I like your answer. We're going to go ahead and just round up to 44 because 0.025 of a foot is it's worth noting, but it's a little bit also, it's okay. We just rounded to the nearest tenth. So 44 feet, what does that mean? To me, it's actually kind of scary. Because 3/4 of a second is actually a normal reaction time. Yeah, the car already moved 44 feet before they put on the brake. So if a kid jumps out in front of you, like the car, it is really, 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 really hard to not hit them. Especially if they're that close, if they just right out. Anyway. Okay, so what I want you to do is I want you to try it. Okay, your turn. So I'm going to give you like, I don't know, a minute, 2 minutes, whatever it takes. I want you to find the reaction. Oh, you know what I'm going to do? Okay, back up. Please don't go away. Okay, I'm going to make this one smaller. So you have your, I know it's smaller. I told you I was going to make it smaller. And then I got to bring it back up though. Like, let's put it over here. Super small. Then we'll go find the question. Okay, so it's your turn. Taylor, I'm just going to delete a little bit of your work so we can see what you're doing. Because you can see it, but I can't. Oh, okay. What do you first need to do, though? Because remember I said reaction distance equals speed times time. The reaction time. But what was our little special deal about the speed? Oops. Yeah, it must be in feet per second. You got it. So I'm just going to rewrite what you said here. And the reason why it has to be in feet per second is because this is also in seconds. So we want to match our stuff. So step one, find that speed in feet per second. Yep, I can. Remember, like looking at the bottom left, see I have 40 miles per hour and I'm converting that one into feet per second. So if we have 65, remember it's miles per hour. I like to write it this way. It helps me know what to do. Um, it's kind of it's a hint. It's a hint. So I'm going to focus on the I don't know. Do you want to do miles first or the hours first? Which one? Okay. So then we know we want to cancel our mile because it's in the numerator, so we want our mile in the denominator. So 1 mile is 5,280. And then change colors because we can. And then now we're going to focus on the hour. So we need it in the numerator. So 1 hour. And then what is the conversion for the 1 hour? Do you want to go seconds or you want to do smaller steps, minutes, then seconds? Good. Except for I totally missed the zero part of it. Oh, you just want to do that one? For sure. Let's go backwards a little bit. Let's undo that. And let's do the conversion straight to seconds. So 3,600 seconds. And then that's a 1-step versus a 2-step. Okay, then what we're going to do is in our calculator, we're going to do 65 times 5,280 all over 3,600. So crunch those numbers. Shoot, gotta get a little better than that. This time I'm gonna care a little bit that it's 95.3 because a third of a foot is 4 inches. So this is feet per second. Now we got to multiply by our speed or reaction time. So this times 0.75 seconds. And just a side note, but kind of important side note, is this is a denominator second and that's a numerator second, so they cancel, and that is why our answer is in feet. And what'd you get for the feet? Oh, do you have the answer and I can't see it? And let's put 74 or 71.5. Yeah, nice. I like that. So it took, when the brain saw something needed to be stopped at and applied the brakes, we'd already gone 71.5 feet. That's why cars are super dangerous and speed is dangerous. Um, and that's why there's speed limits, is because when you're in a neighborhood and you're going 25, well, let's look at it. When we're going 40 miles per hour in 3/4 of a second, we'd only gone 44. But when we increased our speed to 65, we've now gone 71, which, that's a lot. I think it's a lot. Anyway, what do you think, Taylor? Do you have any like moments of, interesting, or that was boring? Yeah. And you know, I mean, people say that cars are weapons, and it's for that reason. Is because even then, this is a sober mind. You know, in the webinar discussion, I push it to what would happen if our reaction was impaired, and so what would be the difference? So one, remember 71.5 feet, really important, because you need to compare that to the other one. But you know, and then we're going to use this one and use our formulas for other stuff. But you know, that's why vehicles, if someone gets hit by a vehicle, it's bad. Um, but because that's just why we're thinking of it. And even if you're like super sober and super paying attention and slam on the brake as soon as you realize it, you still have gone 70 feet before you can slam on those brakes. But anyway, and that's why if you're in a school zone, you get like an insane ticket. So don't ever speed in a school zone. Don't speed, but school zones double your stuff. Cool. Did a good job today, Taylor. So we're just going to do a wrap. That was just reminding us what we could do, and then we're done.